Greetings. I want to give a brief overview of how to approach Module 2 Homework Assignment Problem 3. I'll show you how I would do it. Bear in mind that the numbers in my version of the problem will be different than the numbers that are in yours. So in this problem you're given this arrangement of three vectors. Well, basically you're given two vectors, VA and VB, and then we're going to form the vector sum of those two, which gives us the vector V total. And we're told that the magnitude of the sum, which I'm going to write down here, so V total, that magnitude is 4.5 meters per second. We're also told that in my case, that theta 1 is equal to 25 degrees and theta 2 is equal to 15 degrees. And in the first question, part A, we're asked to find the magnitude of the vector VA. So VA magnitude equals question mark. So now, how can we approach this? Well, first of all, let's just note that this angle, theta 3, we'll probably need it, and that's easy to find because theta 3 is just going to be, we use the fact that the sum of the three angles in the triangle have to be 180, so therefore theta 3 will be 180 minus theta 1 minus theta 2, and so that will be 180 minus 25 minus 15, which gives us 140 degrees. Okay, now we're trying to find the length of V sub A, and we know what the length of V total is. We also know what this angle, theta 3, is. So I'm thinking maybe we can use a nice result or formula from trigonometry, namely the law of sines. Law of sines. And so the law of sines tells us that the length of one side of the triangle, so in our case I'll start with the V total, and then that length divide by the sine of the opposite angle, which would be sine of theta 3, is got to be equal to the length of another side divide by the sine of the opposite angle, which is theta 2. Okay, so since we know V total, we know sine, we know theta 3, therefore sine of theta 3, we know theta 2, therefore sine of theta 2, we can find a formula for the magnitude of that that sine. So V sub A is going to be equal to V total times the sine of theta 2 over sine theta 3. So, looking at this triangle, since it's not a right triangle, you might think of going back to your trig formulas and seeing what relationships are available for non-right triangles, and law of sines is one of those that's available. So you could do like a Google search on trigonometry formulas, and you'll likely find a nice listing of those important formulas from trigonometry. Okay, so whoops. So v sub, putting in the numbers, v sub a is going to be equal to 4.5 times the sine of theta 2, which is, for me, that's sine of 15 over sine of 140. And so get my calculator. Yeah, putting those numbers into my calculator, I'm getting 1.812. And I know that'll be meters per second. Okay, so that would be part A. Okay, so for part B, we're supposed to find the magnitude of the vector VB. So that's our question. And we'll do it with the same approach. I mean, basically, once we recognize that this is a situation in which the law of sines can be useful, then that pretty much offers the strategy for solution. So in our case now, we will have V total. Using the law of sines, we would have V total divided by sine of theta 3, and then that's going to be equal to the magnitude of VB divided by the sine of the opposite angle, which would be sine of theta 1. So therefore, VB is going to be V total times sine theta 1 over sine theta 3. So I can put in the numbers. 4.5 times sine 25 divided by sine of 140. Okay, so putting those numbers into my calculator, I'm getting 2.959 meters per second. So for the computer grading, you would want like 2 digits to the right of the decimal point, but I keep an extra one throughout the calculation just to make sure I'm getting enough digits. Okay, and so that would take care of that particular problem. So we see that kind of my logic was, all right, I'm dealing with a triangle up here that is not a right triangle. So, I don't have some of the obvious trig equations to deal with. So I asked myself, well, what do I have? If I go back to my trig, what formulas do I have for dealing with a non-right triangle? And law of sines, law of cosines, those would be the main ones that you would have to deal with. Recognizing that the law of sines will give me information on what's asked for, that's the direction that I went.